Do you have your notes out from yesterday? Let me see this, please. That's the one. There's some. Oh no, the Monday's notes. The Monday. I'm gonna borrow this real fast, please. On Monday's notes, on the back, it says, if your entire expression is a fraction, observe, rewrite it as two fractions with the same denominator so that you can simplify. Thank you. This is not 100% mathematically necessary, but I will have you do it because it makes the rest of the problem easier. And reduce your chances of simplifying incorrectly. Okay. So this is me just separating it into two fractions. I can simplify this. Hayden, what can I divide out of these two numbers? What can I divide out of those to simplify? 3, right? So that leaves me 7/4. And then here, underneath, and you all pretty much simplified your radical correctly. You got I for the -1, and then pulled out that 3. 3I rad 7/12. But right here, you can simplify one more thing. You can simplify that 3/12, right? What is 3/12 as a simplified fraction? 1/4. So it's 7/4 plus I radical 7/4. Do not combine it back to one whole fraction. Just leave it like that. The reason why we like it still like that is it's easy to say, oh, look, A is 7/4, and B is the square root of 7/4. Okay, that's harder to see if you combined it back into one fraction, especially because sometimes the fractions simplify with different denominators. Questions about that one? Okay. The other problem is a whole different kind of problem. First of all, what it's not is, it's not a FOIL problem, although it feels like one, because there's 2 parentheses with 2 terms inside each one. So it feels like, oh, hey, I know how to do that. First, outside, inside, last, multiply, multiply, multiply. But we're not multiplying here. And then a lot of people, I didn't anticipate this when I wrote the problem this morning, but thought it was 2 separate problems. I think they just didn't notice the plus in there. But most people began correctly, which was by simplifying the radicals. So this radical is -1 times 9 times 8. This one is -1 times 25 times 2. And so after you simplify, oh wait, sorry. I like 36 and 2 better. Um, 6I radical 2, and then 8 plus 5I radical 2. And then yesterday was when we did operations on complex numbers. This is a plus, an addition of 2 complex numbers. And from our notes yesterday, it said combine the real pieces and then combine the imaginary pieces. What are the real pieces here? 8 and -7. That gives me 1. The imaginary pieces are the -6I radical 2 and the 5I radical 2. So let's talk real quickly again about how to add or subtract radicals. So here's this one I'm looking at, and here's this one. When adding or subtracting, the radical part stays the same. It's not going to change. What you're doing the math on is the coefficient out front. So the -6I here and the 5I there. So the radical 2 doesn't change, so I'm going to go ahead and write that down. But what is -6I and +5I? What does that add to? -1I, right? And so that's how to do math, add and subtract on radicals. So it's 1 minus I radical 2. And several people have asked me today, well, what would you do if the radicals were different? There's nothing to do. You would just bring them down into your final answer. It's the same thing as if I had 3x plus 2I. I wouldn't be able to do that math. I would just bring it down in my final answer. Anything else you need clarified about that second problem? Mm-hmm.
So if there was like
Yeah, you would just leave it like that. So if I had like this one here, and then plus an I radical 2 plus an I radical 3, you just leave it like that. There's nothing you could do. You can only combine like terms, and because the rads are different, they are not like terms. Okay. Any others? Any other questions? Thank you for your question. And I'm not being patronizing. I was not being patronizing. Homework questions. Oh, that's right. I forgot to give you your homework yesterday. Gosh, I was failed all over the place yesterday. Okay. Skill check. So we're using this chart for grading today since there's just the one problem. 100 for perfect if your answers are just like mine. So the problem asks to write it in A plus BI form. This is A plus BI form. So even if your numbers are correct but you flipped it, that would be a 95 for a simple mistake. Okay. If your numbers are correct and you forgot to write your A and B like this, I would say that's a 95. That's a simple mistake. However, if you put an I in your B, that's a procedural mistake. That's an 85. Okay, because it's not asking for that part. It's asking for the coefficient of I. That's a conceptual misunderstanding. If you put no I's, 85. Conceptual misunderstanding. That's about all I got. Does anybody else have a specific situation that they want me to address? If you feel like you made a combination of math and conceptual mistakes, that's a 75. 65 if, bless your heart, you just tried really hard, but you didn't really get anything right, but your math kind of looked like mine, like you knew something about what you were doing. And if you just had zero idea and you left it blank, that's a 0. That's an IDK. If you gave me IDK, that's a 0. Please be sure your name is on there, your grade is on there. Pass them to the back. People in the back, please put them on my desk. And then we have a lesson. Oh, here's one more. No. Don't be mean. Don't be mean first. I saw a thing the other day on Facebook. It said some parents run a tight ship. I run a pirate ship. There's drinking, swearing, and occasional mutiny from my crew. I was like, that's my house. Right. The children aren't drinking though, just for the record. Just so you know, it's all me. Okay. So today's lesson: complex conjugates. I was recording that. Oh, why do I do that? Okay. I went to go start it, and I was like, it is already started. Okay. Man, dang it. Okay. I have to recover. I'm quite embarrassed. That's like anyone's ever going to listen to that 5 seconds. Okay. Complex conjugates. Sorry, let's do math. I apologize. What we're talking about today is still complex numbers. I really will start the lesson now. Hold on. Complex conjugates, complex referring to complex numbers. And a conjugate, so this is my generic form of a complex number, a plus bi. This is what we call a complex conjugate. What are similarities and differences that you see there? What are some things that are the same in those two expressions? The variables are all the same, right? Okay, the A is the same, the BI is the same. What's the only difference? Positive, negative, right? One is an addition, one is a subtraction. So when we're talking about conjugates of complex numbers, a conjugate is formed by changing the sign of the imaginary part. See you tomorrow. Changing the sign of the imaginary part. And I'll tell you why we would even want to do that here in just a bit. The next thing I'm going to write down, I really don't want you to write down. I kind of just want your attention. The other day, we talked about something that looked like this, 3 radical 5. And what did we not like about that? But there's a radical in the bottom. How did we handle that? What did we do? Multiplied by itself on the top and bottom, right? And what did that do to the bottom that made us happy? Got rid of the radical, right? Because square root of 5 times square root of 5 is 5. And I told you that what we didn't like about it in the bottom is it's hard to divide by an irrational number. Okay, and so we changed it to a real number, or a rational, we rationalized it. But instead of 3 over square root of 5, if we had had a binomial on the bottom, 1 plus square root of 5, we might feel like, oh, okay, well, we're just going to do times radical 5 again. Let's try that and see what we get. We'd still get 3 radical 5 on top. But when I take both of these terms times that radical 5, I would now have this. 1 times radical 5 plus rad 5 times rad 5, which is 5. I did not improve my situation, right? I still have a what in the bottom? A radical. Okay. What we could do instead is multiply the bottom by its conjugate. And this is something you've seen before. A conjugate looks like this. You keep these two terms the same, but you change the sign on the second one. And you would do that to the top and bottom. And what would happen is all the radicals would drop away once you do the math. You would do the FOIL, and this magical stuff would happen where everything's gone at the end. This is the same process we're doing today, but with complex numbers, with i's instead of radicals. We also don't want i's in denominators. Now, we won't be doing any fractions today. We're only going to be practicing determining what the conjugate is and then finding the product of them. And so that's the main point of today's lesson. So this we're skipping because it didn't go over well third period. They almost died, and I didn't want the rest of my classes to almost die as well, so we're skipping it. We're going to go straight to this example. So this first example right here, 2 minus I want you only for a second to write down what you think the conjugate is. We're not going to even do the math yet. Just write down what you think is the conjugate. And raise your hand when you have that done. So I can just see where we are. Thank you, thank you. Thank you. Thank you. Thank you, thank you, thank you. So a conjugate means you're just changing the sign of the imaginary part. That's it. That's the only change you're making. Does anybody want to volunteer what they wrote? Yes. 2 plus I. That's correct. Raise your hand if you wrote that. All right. 2 plus I is correct. So that's the first part of the problem. For each complex number, name the complex conjugate. And now we're going to find the product of them. Product means which operation? Multiply, right? Now we're going to multiply those two things. And this is where the magic comes in. And maybe you think magic is a strong word to use in mathematics class, but I like it. So we have these two binomials. You can do FOIL, remember? You can do box method, whatever you like. I do double distribute, so I take the first term here and distribute it through. That gives me 4 plus 2i. And then I take the negative I and distribute that through. That gives me minus 2i and then a negative I squared. And here's the magic. What happens to those two middle terms? They cancel out. That will happen every time you're multiplying by conjugates. That is by design, because the opposite signs here make that happen. And so then I've got 4 minus I squared. And I just told you that this whole process was to get rid of the I, but it looks like I still, bless you, have an I. However, what did we learn yesterday about I squared? It equals negative 1. So we can replace that I squared with a negative 1. And so now I have 4 minus, so there's the blue minus is the subtraction part of the problem. The red minus is from the I squared. So you do have to be careful in these problems with the negatives that are floating around everywhere. And then minus a negative is plus plus, so the answer is 5. For the second one, write down what you think the conjugate is. Before you do math, just write it down and we'll make sure we're all on the same page before we go forward. All right, I have 3 options up here for you. 2 are the most common mistakes. 1 is the correct answer. Okay, so you tell me. If you have 1 as your conjugate, raise your hand. 2 as your conjugate, raise your hand. 3 as your conjugate, raise your hand. Right. It is 2. Okay. Oh, did I have the same thing? I'm so tired. Oh. I meant to have, I was wondering why he raised his hand twice. I was like, does he have the same? He just told me. I meant to put, I don't remember what I meant to put. 2 is correct. Who put 2? And 3. Congratulations. Okay. All right. It's just Wednesday, right? It needs to be Friday. All right. So what we're going to do now is multiply by the conjugate. I want you to go ahead and try that for a minute. It's a pretty straightforward problem except for one part at the end that's very high maintenance, but I want you to struggle with it for a moment. It's called productive struggle. It's good for you. Okay. So the hardest part of the problem was when you get to those last terms, I read 5 times I read 5, right? You all did pretty well the rest of the way. Like when you distributed -1, -1 times -1, positive 1. -1 times that is positive I radical 5. And then distributing this one through, -1 times I radical 5. And then here's the one with the most room for error. Okay, it's these last terms. So I'm going to do it one little piece at a time. What's plus times minus? Okay. What is I times I? What is square root of 5 times square root of 5? 5. Okay. You're all overthinking that step. That's okay. That's what we're here for, to get your misconceptions cleared up. So then what happens to the middle terms? They cancel out. They're gone. Those i's are out of there. And then I have minus of 5i squared. So we got to be careful again with our negatives here. What is I squared? This is -1. This is not 5 minus 1. This is 5 times negative 1. So I've got 1. This is the subtraction from the problem, this blue minus. And then 5 times that negative 1 is negative 5. Right? And then the minus minus becomes plus plus, and that is 6. See how there are no more i's? Right? That's what happens when you multiply by conjugates. The radical or the i's or both, they cancel out. Okay? We'll finish this lesson tomorrow, but I am going to give you your homework so you can do some of it.